All right, welcome back to the continuation of our PowerPoint presentation on the sun and heat and light. So we left off with a brief explanation of the nuclear fusion being how the sun produces heat and light. Now, the World Nuclear Association explains that fusion powers the sun and the stars as hydrogen atoms fuse together to form helium, and matter is converted into energy. Hydrogen, heated to very high temperatures, changes from a gas to a plasma in which the negatively charged electrons are separated from the positively charged atomic nuclei. So normally, fusion isn't possible because of the strong repulsive electrostatic forces between the positively charged nuclei prevent them from getting too close and to collide with the fusion to occur. So, however, if the conditions are such that the nuclei can overwhelm the electrostatic forces to the extent that they can come very, very close, and then the attractive nuclear force between the nuclei will outweigh that electrostatic force, allowing the nuclei to fuse together. These conditions occur when the temperatures increase, when the ions move faster, and eventually reach speeds high enough to bring the ions closer together. Then the nuclei can fuse. This causes the release of energy. Okay? Gives off the energy, and that's why we get the heat and the light. Okay? So this comes from the core of the sun, and it's due to the thermal radiation and then to the surface of the sun through convection. At the surface of the sun, the energy is roughly about 570 degrees Kelvin. And from the energy travels through space where it is trapped by the atmosphere. Okay? And this is where we're going to include the Earth a little bit. And the greenhouse effect, it happens when all that energy is trapped. And it travels very long time to get there. It actually travels a whole AU. We'll get into that though. But to more specifically define the greenhouse effect, we ask an article from Life Science, and they say that Earth is constantly bombarded with enormous amounts of radiation, primarily from the sun. This solar radiation strikes the Earth's atmosphere in the form of visible light, plus ultraviolet light, infrared, and other types of radiation that are invisible to the human eye. The exchange of incoming and outgoing radiation warms the Earth, and often referred to as the greenhouse effect because the greenhouse works much the same. All right, and what you have to understand here is the coming and going of this constant radiation is why the Earth is here. Okay, it would be way too hot or way too cold without it, and it's just extremely important. Now that light coming off the sun has to travel an astronomical unit. Okay, that's 807 miles. Okay, the energy produced by the fusion is transported to the solar surface and emitted as light. The energy that the Earth receives as light. Okay, so this is very important because this is how far it has to travel. So then we're going to go into another explanation of how the nuclear fusion is created. And this is kind of like my dumbed down version. So, 3 steps, okay? And we're going to start with the chemical reaction taking place inside the sun can be broken down. First, the formation of the deuteron. When the deuteron and the proton collide inside the sun, they form a helium-3 nucleus, creating the second part of the process. And this creates the fusion energy. The helium-3 nucleus is not a typical nucleus since it has 1 neutron and 2 protons. The last step of the fusion creation is the helium-4. So when these helium-3s collide, they form the helium-4s and then 2 extra protons. The 2 extra protons, they just kind of release. But basically what we need to take away from here is definitely the E equals mc squared. And this is old Albert Einstein's famous quotation that supports the fact that total mass of both the protons and electrons is destroyed, creating the energy. Okay? It's a big part of it. Now, the Earth, its climate is determined by the sun. Okay, we all know that. So, but there's different, just like the sun, from the core comes the heat. So you have your tropical, your temperate, and you have your polars. But the Earth's processes could not work without the sun providing light and heat. The sun's light afford energy for most life forms. Plants, sunlight, water, everything is here because of the sun. The sun's heat on the Earth's surface and atmosphere provides energy to move the atmosphere and oceans, producing winds, ocean currents, water cycles, lots of different things. That is extremely important. Okay, main thing to take away is that basically the answer to the question, how does the sun produce heat and light? It's simple. It's nuclear fusion, okay? It's hydrogen converting into helium, all right? And this creates energy from the core, and it comes out from radiation, and then also to the heat, to the surface is convection, all right? Heat and light are the two major types of energy. That's essential to what the sun is, one big ball of energy. Because of nuclear fusion. The nuclear fusion reaction, in which two or more atomic nuclei come close enough to form one or more different atomic nuclei and subatomic particles. Okay? That's basically it. Sorry, it was so long, but we got it done. Here are the references, and thank you so much for watching. Bye.